Hello, math humans. We're going to do 9.5 today. We're going to be talking about the binomial theorem and Pascal's triangle. Our objectives are that we're going to learn how to expand binomials using either the binomial theorem or Pascal's triangle. So let's just first talk about a binomial. So let's say a binomial is a plus b. Well, if I have a plus b, and actually, let's just start, and I want to raise that to a power. Well, a plus b to the 0 power is going to be 1, because everything raised to a 0 is going to be 1. Well, if I have a plus b raised to the first, that's just 1a plus 1b, okay? And the ones will make significance in a moment. Well, then if I take a plus b and I raise it to the second power, it's going to be 1a squared plus 2ab plus 1b squared. Well, if I want to raise it to the third, a plus b to the third, I could do a plus b to the first times a plus b to the second. Well, I know this one and I know this one, but that's going to end up getting a little crazy because that's going to be a plus b times a squared plus 2ab plus b squared. And then what if I wanted to do a plus b raised to the 10th power? Oh my goodness, we could be here forever. So there's an easier method, and the first thing that I'm going to talk about is Pascal's triangle, because it's really a cool math piece of trivia. So notice that when I did a plus b to the 0, I got a 1. And I'm just going to look at the coefficients. When I did a plus b to the 1, so I'm going to call this the 0 row. And when I did a plus b to the first, I got a 1 and a 1. Well, this is going to be the 1 row. And then when I did a plus b to the second, I got a 1, a 2, and a 1. So 1, 2, 1. This is the second degree. So I guess I should call this the first degree to be more consistent, okay? Well, when I get to the third degree, I actually didn't do that math, but I can generate it by doing this. The outside edge is always going to have a 1, okay? So there's my 1. I'm going to add these two together to get a 3. I'm going to add those two together to get a 3. Here's that outside edge, and I have a 1. So that's my third degree. So then on my fourth degree, I'm going to bring down the 1 on that outside edge. I'm going to add those two together, 4, 6, 4, and then here's my 1 on the outside edge. And then if I did the next row, it would be 1, 5, 10, 10, 5, and 1. Okay, there's a couple of things that we want to notice. This is called Pascal's triangle, and these are going to give me the coefficients as I expand a binomial. The Pascal's triangle is symmetric because it turns out that it is an isosceles triangle, so it means that the legs are equal. Okay, when I drop a vertical line, it's going to bisect the base, and then it's going to be symmetrical about that line. Yay, geometry. Okay. Each of the rows, so notice that this was a second degree, and it had 1, 2, 3 terms. This is third degree. It has 1, 2, 3, 4. Down here on the fifth degree, it should have 6 terms, so 1, 2, 3, 4, 5, 6. So there's always one more term than the degree, okay? So now what I want to show you is if I was actually going to expand this right here. So if I wanted to do a plus b to the third, then I'm going to use the third degree row. And so it's cool to notice that I'm going to have a 1, and then I'm going to have a to the third, and then b is going to be to the 0, okay? And you can't see it. That's a bummer. So then the next term is going to be, there's that coefficient 3, and then I'm going to have a to the second, b to the 1. The first term is going down in power. The second term is going up in power. Okay? The next one would be 3a to the 1, b to the second. So notice my a's have gone 3, 2, 1. Then the next term is going to be a 1. A is technically going to be to the 0. B is going to be to the 3. And now I've expanded a binomial using Pascal's triangle and the coefficients that are generated by using Pascal's triangle. So sometimes we can do the math, and I have the Pascal's triangle memorized down to the 5th row. So if I want to expand something to the 4th degree, so if I wanted to do a plus b to the 4th, I just write down 1, 4, 6, 4, 1, my coefficients, and then I would actually start doing the math because I have these coefficients memorized. So to the 5th degree, that's pretty easy to memorize, but what if you wanted to do something like a plus b to the 10th? Well, it would make absolutely no sense to expand Pascal's triangle to 10 rows because those problems would take forever. So actually, the numbers in Pascal's triangle can be generated by using something called a combination. And a combination says how many different ways can I order a group of numbers. Okay, so I want to know how many ways could I order a group of numbers, and in a combination, the order is not important. So I'm actually going to start with row 3. So remember from Pascal's triangle, row 3 had coefficients of 1, 3, 3, 1. This is a math term. It's combination of n choose r. So it's n things chosen are ways. Okay? This term is the combination of 3 because it's the 3rd degree, choose 0. We always start our triangle on the 0 with the 0 term. This is going to be the combination of 3 choose 1. This is the combination of 3 choose 2. And this is the combination of 3 choose 3. Now, if you wanted to do something like a plus b to the 10th, my coefficients, and I'll show you how to generate these in your calculator. The first one would be the combination of 10 choose 0, and this is going to be a 1, and then I would do the combination of 10 choose 1, and then I would do combination 10 choose 2, and it would go all the way until I got over here to the combination of 10 choose 10. Remember from Pascal's triangle that the first and the last terms are always 1. And then the next term, the combination of 10 choose 1 is going to be a 10. So because the rows are symmetric, I can fill in from both directions. And so then I could find my coefficients. Okay? All right, so let me show you how to do this really quickly in your calculator. So let's say I wanted to do the combination of 10 choose 9. I want to do this one right here. So I'm going to do 10. And then I'm going to go to math, and then probability. And I went to the left, but you can go to the right. It's 6 of one, half a dozen of another. And notice that option number 3 says that's the combination of n choose r. And so I'm going to choose option number 3. So I'm going to do, I wanted to choose 9, and I hit enter. And notice that I get a 10. Yay, I got a 10. So you can do those in your calculator. Let's do one more. Let's do the combination of 10 choose 8, just so you remember. So I do the how many first, 10, math, I'll go this way, probability, 3, and I want to choose 8, and that number is 45, okay? And interestingly, my combination of 10 choose 2 would also be 45. So if I do second enter, and I bring that right back up, and I edit and get a 2, Notice that it's 45. So Pascal's triangle is really, really cool because you can generate the terms in so many different ways. All right? So let me move us through a problem. Let's actually start doing an example. Actually, before we do that, I lied. Let's talk about shorthand. Anytime you're trying to generate these terms, you could write the combination of 3, 2, 0. You could also write it this way, and that notation means this is a combination of 3, 2, 0. You're still going to do this in your calculator, but if you want to write it using some shorthand for math, this would be the combination of 3, choose 1, and this would be the combination of 3, choose 2, and this would be the combination of 3, choose 3. Okay? So let's do an example. It's going to be our first example, and it's going to say expand, oops, spelled it wrong, expand the binomial, and I'm going to have x plus y to the fourth. Now the math on this is tedious, and I would recommend that you not skip steps the way I'm going to show it to you, and I'm showing it to you in an organized manner, which means it'll make your math a little bit easier. If you remember from Pascal's triangle, from row 4, the coefficients are 1, 4, 6, 4, 1. So now I'm going to start writing. So when I do x plus y to the fourth, I always write my coefficient first. The first variable starts at the highest power. The second variable starts at 0. And then I'm going to write down my coefficient 4. X is going to decrease in power. Y is going to increase in power. And then I'm going to write the 6, because I always write my coefficients first. X is going to go down in power. Y is going to go up in power. And then I'm going to write the 4. X is still going down. Y is still going up. And then the last one, X is now 0, and Y is going to be to the fourth. And then I clean this up, and I would write that this is x to the fourth plus 4x cubed y, 6x squared y squared, 4x y to the third, and then the last term is y to the fourth. And then, of course, I report my answers well. So it's actually really easy. It gets entertaining when I start adding values to my equation. Okay, and I'll show you one of those soon. So let's do another example. And we're still going to be using Pascal's triangle, technically. So expand the binomial. And only the first 4, oops, spelled that wrong too, terms. Okay, so this time I want to do x plus y to the 20th. Okay, oh man, but I only want to do the first 4 terms. So the first thing that I'm going to do is I'm going to show you what my coefficients would be. Notice that I'm raising it to the 20th power. So my coefficients, the first one would be 20, choose 0, and then I would have 20, choose 1, and then I would have 20, choose 2, and I would have 20, choose 3. Remember that every row in Pascal's triangle starts with a 0, or it starts with a 1, so I can just put that in there. And then the next term is always the power. And I'll show you this math just to verify. So I'm going to use, I already have combinations in, but I'll show you just how to make sure that you remember. So I went to my probability 3. So I'm going to do the combination of 20, choose 0. And notice there's the 1. If I hit second enter and I go back and edit and put in a 1, there's the 20. Second enter and I go back and edit, there's the 2, and I get this is 190. And then second enter, go back and edit and put in the 3, and this is 1140. Because we're raising something to the 20th power, the coefficients are huge. Okay? So now what I'm going to do is kind of come over here. If I have x plus y to the 20th, my first term had a coefficient of 1. That's going to be x to the 20, y to the 0. The next coefficient was 20, x to the 19, y to the first, and then I would have 190 x to the 18 y to the second, and then the fourth term would be 1140 x to the 17 y to the third. So let's talk a little bit more about the coolness of what we've just done. So let's look at the exponents. Notice that 20 plus 0 is 20. 19 plus 1 is 20. 18 plus 2 is 20. 17 plus 3 is 20. So the exponents are always going to add to give you the original power. Alrighty? The next thing that I would have you notice is if I wanted to do this with combinations and I wanted to generate let's say I want to generate the 11th term. So that's going to be the combination of 20, choose 10, because remember I start every row with the 0, so 0 to 11 is going to be 10, right? And then I'm going to write my x and I'm going to write my y. Notice that these numbers always match. Well, if this is going to have to add up to 20, now I know that that's there. And then I could actually do that math in my calculator. So if I bring in my handy dandy grapher and I do second enter and I go back and change that to 10, then this term is going to be 18,756 x to the 10 y to the 10. So it's actually really, really cool because I can generate any term of the combination or the expansion that I want. Okay? So now let's do another example where I bring in some numbers. So this is going to be example number 3. Okay? And in this time, I'm going to have 2x minus 3y to the 5th. Okay, so notice that now I have numbers that are going to be raised to a power as well as variables. For the 5th row, it's 1, 5, 10, 10, 5, 1. Okay, so then we're going to start doing our math. I highly recommend, again, I can't say it enough, that you not skip steps. So if I start, I also need to be very careful with my parentheses. So when I start writing, here's the first term. It's going to be 2x to the 5th and negative 3y to the 0. Notice how I wrote that down. I'm putting the entire thing in parentheses, which eventually means that the exponents are going to apply to everything inside the parentheses. Then I have the next term. Here's the coefficient. It's going to be 2x to the 4th, negative 3y to the 1st. The next coefficient is 10, and then it's going to be 2x to the 3rd, negative 3y to the 2nd, and then I have another 10, 2x to the 2nd, negative 3y to the 3rd, okay? All right, I'm just checking my math. I went 5, 4, 3, 2, this is good, plus 5 times 2x to the 1st, negative 3y to the 4th, and then my last one is 1, 2x to the 0, negative 3y to the 5th. So that's step number 1. Step number 2, I'm going to manage all of my exponents. So this is 2 to the 5th. This term goes to 1. This term goes to 1. So I'm not even going to write it, and then I'm going to write x to the 5th. Numbers always play together. Variables always play together, so I'm going to separate it. And the numbers are all multiplied together. Okay, so in the next term, here's the 5, and then I have times 2 to the 4th and a negative 3 to the 1st, x to the 4th, y. Okay, and then the next term, here's the 10, 2 to the 3rd, negative 3 to the 2nd, x to the 3rd, y to the 2nd. Next term, here's the 10. I'm going to have 2 to the 2nd, negative 3 to the 3rd, x squared, y cubed. And notice what I mean, we have a lot of writing to do. 2 to the 1st, negative 3 to the 4th, x, y to the 4th, plus 1, negative 3 to the 5th, y to the 5th. And this is a step that I really recommend that you don't skip, okay? So now I'm going to start using my calculator to help me with numbers. I actually know the first one. 2 to the 5th is 32, x to the 5th. Yay, got the first term done. And then what I would do as I log back in and hit the wrong password. Come on, computer. That's what happens when you don't touch your computer. It locks up. So 5 times 16 times a negative 3 is a negative 240 x to the 4th y, plus the next one, 10 times 8 times a positive 9 is going to be 720 x cubed y squared. And then as I move down the line and I write all of my terms, plus 810 x y to the 4th, and then my last term is minus 243y to the 5th. I report 2x minus 3y to the 5th because every single answer has to be reported, and ta-da, I'm done. So it's actually really, really cool, okay? So another thing that I need to point out, because now we have used Pascal's triangle and we have technically used the binomial theorem. So the binomial theorem generates Pascal's triangle, okay? So when a problem in the book asks you to use the binomial theorem, those are your combinations, 20, choose 0, and then combination 20, choose 1. Pascal's triangle is just going to be the coefficients. So really, in essence, these two are interchangeable because the binomial theorem generates all of the coefficients in Pascal's triangle. In Pascal's triangle, I can get all of the numbers by doing the sums of the previous row's numbers, but it's really kind of cool that we use the two of these things interchangeably. All right, let's move on to example number 4. Okay, I'm just checking. We have this one and one more, and then we are done. I want to find the 6th term of the expansion a plus 2b to the 8th. Okay, so I'm going to manage this technically with the binomial theorem because I'm going to start using a combination because I don't know Pascal's triangle to the 8th power, nor am I going to try to generate the terms. So I'm going to start by writing, this is the combination of 8, choose 5. Remember, if I start on 0, it would be the 0 term, 1st term, 2nd term, 3rd term, 4th term, 5th term, and this is 6 terms. So the combination of 8, choose 5, I'm going to write down my A and I'm going to write down my 2B. These two numbers always match, so I'm going to put a 5 there. The coefficients have to add, these guys have to add to give me the 8. Well, now I just finished this. I can do the math in my calculator. The combination of 8 choose 5 is going to be 56. The a to the 3rd, and then 2 to the 5th is 32b to the 5th. So now the 56 and the 32 play together, and the variables play together. And so the 6th term is going to equal 1792 a to the 3rd, b to the 5th. So I think combinations are really pretty cool in Pascal's triangle because I can generate terms with all of the unique way that the numbers play together. All right, our last example, example number 5, says find the coefficients. So in this one, all I want is the number out front of the term a to the 6th, b to the 5th in the expansion of 3a minus 2b to the 11th, okay? So I'm going to fill in what I know and kind of work backwards, just like we did in the previous problem. I want the 5th term, so I'm going to do the combination of 11, choose 5, because remember the last ones match. And then I'm going to write my first term is a 3a, my second term is a negative 2b, Now I know that this is going to be a 5 because these guys match. 5 plus 6 is going to give me 11, and now I just do that math. So the combination of 11 choose 5 is going to be 462. Then I'm going to have 3 to the 6th, a negative 2 to the 5th, a to the 6th, b to the 5th. So I got what I was looking for. Now I just have to find the number, and then the coefficient, when I do that math, is going to equal a negative 107775536. I've identified my answer, and then I've gotten my solution. Alrighty, that is it for today. I will see you soon.